I guess our game plan is the following. We're going to spend a few minutes here, I don't know, 30, 45 minutes, looking at going through these small these small exercises. There's a couple I didn't do and they're basically models that are small, closed and open economy models. They're very trivial, but I wanted to do is use those to show how MPSGE works, because we have the WinDC framework. Our generic framework is MPSGE. I like to try to translate these into an algebraic model, but at this point we have the GTAP WinDC models in MPSGE. So rather than introduce MPSGE together with the bigger model, I thought what I'd do is to use the small models to motivate what the logic is of how this works, and then we'll see. I mean, MPSGE is one of these things where there's this learning curve to get a feeling for it. And Jim and I both, Marks and I both come to the conclusion that we're much better off to teach stuff algebraically where you write out equations, because then you understand what's happening. And when you get comfortable with that, then you're much better at using MPSGE. If you learn MPSGE before you've learned how to write the equations, you can not really be aware of what you're actually doing. And so that's the idea. So if I share my screen here.
All right.
Thursday's done. GMS models exercises. Q1, Q2, is it Q2 was, nope, Q3. Yeah, so Q3. So I'm going to begin with Q3. So Q3 is this simple little model with two consumers. And just looking, we did this yesterday in class. So if we look at this guy, price of goods, we have two market conditions. And then we have a Marshallian model. Oh, maybe we should, okay, then we have consumer A and consumer B, and then we have the model down here. So this is the model we have is basically, it's a fixed supply model where consumer A owns X and consumer B owns Y, and we change something. So let's think about how this model works. If we then go down below, so I'm going to say here is implement the model. Second model using MPSGE. So MPSGE actually predates GAMS. So MPSGE was the framework, but MPSGE goes back to, oh, maybe I have some lecture notes about this as well. So I can. I'll find the lecture notes. I have some lecture notes, so I won't do them right now, but I have some lecture notes. It goes back to before GAMS. It was at a time when we were working on algorithms for solving complementarity problems. That was my PhD work, was on implementation of a Newton method that handled boundaries. And during the work on that algorithm, I got frustrated because I wanted to test to evaluate how we worked relative to other algorithms. And it was annoying that every time I wanted to implement a new model, I spent more time getting the equations implemented as the Fortran code implemented to evaluate the equations than I did actually working on the solver. I was spending more time working on the model than I was on the solver. And I just said, I just want to do one set of function evaluations that I can use for all these models. And so I developed this little shorthand method of representing models, and that turned out to be very valuable. That turned out to be the most useful thing that I developed in my thesis. And so what I did was then I started, when I got a job in an econ department, I was working on developing a model, again, working on data sets. I found that GAMS was really good for working on data because you could optimize and you could do stuff. And so I then started to figure out, I'd do the work for the data work in GAMS, and then I'd pull the stuff into my little language to solve the models. And then over time, I gradually, that link anyway, I just discovered that it was possible to move the thing into GAMS completely. So within GAMS, MPSGE does not operate independently, but it's invisible to GAMS. So within the GAMS code, we put in an on text block that says, okay, we're doing something that's a comment. I'm going to give a model, which is going to be, this is the G version of the MPSGE model. And this guy, there's no sectors here. So commodities will be, and if I look at what my models were up here, we have to be careful if we want to share variables between the two. They have to be non-negative, so there's fine. So if I say in MPSG, I'm going to say those are the two prices we have in this model. And one of the differences, and again, this is just inherited this from from early on, is that in MPSG code, the comment, the description of the variable has to have a bang, has to have an exclamation. That's just something we inherited from. That was my inability to write good, to do the more complicated parsing in Fortran meant I want to look for the star sign, and that's where the comment comes from. So that's the two comments. And then I'm going to say consumers. And then I'm going to use the same variables we have here. The descriptions are the same because that's exactly the descriptions. It's exactly the same model we have. So here, now if we go back and we say, okay, well, what's our demand functions look like? We have two consumers. And so what is a consumer in a general equilibrium model? There are two types of information we need to describe a consumer. One is what's its endowments, so what good does it owns, and what's its demands, so what does it consume. And so I'm going to say demand. So this is going to be a demand block for cons A. And now I have the screen split. I'm looking down below to see what he's got. I'm going to have an endowment E of PX, and the quantity is endowed with is X endow times 100. So that provides the endowment. So that defines the endowment. And then I'm going to say, what does he demand? Well, he spends when the prices are equal to 1, he buys 50 units of, and when the prices are all equal to 1, he spends 50 units on A, on X, and 50 on Y. So I'm going to say his elasticity of substitution, it's Cobb-Douglas, is 1. He demands at the reference point, demands 50 units of this, and the reference price involves 1, and demand PY, quantity 50, when the reference price involves 1. That's the whole model, right?
Okay.
So now I've written down a reference point, I've written down what its endowments are, and now I have the same thing go on for B. So cons B looks like this, except cons B is the same as cons A, except he's endowed with Y, and then he has Y endowed times 100.
And what was the exclamation point?
It just is.
It
says the exclamation mark says the comment goes after here, the description of the variable. And if I look at the GAMS model, if I look at in the GAMS, you simply have the name of the variable, and then you just start writing some white space, and then you start writing the description. In MPSG, my programming ability was such I wanted to look for where the description started, and so I did it that way. It's a pity that I did it that way, but the bang just simply says, okay, the trailing comment that describes the last variable starts here. That's just something that that goes back before GAMS. And to be honest, I was a little bit, when I first was developing, when GAMS came out and started to have nonlinear coefficients, I was in a little bit of competition. I thought, I'm not going to change to what they're using. At the time, I didn't appreciate that GAMS was going to become so good. Right? And when I first developed MPSG, one of the reasons, the advantages of MPSG is my function evaluator was way better than GAMS. So you solve models in MPSG, you could get much better performance than you do with GAMS. And now it's completely switched. The GAMS function evaluators are really good. And so there's not, anyway. So that's the whole model right there. And that's the whole thing. We say, okay, now sys include MPSG set GE MPSG. So there I say, MPSG says, do the setup, go. I'm talking to MPSG, I say, go to the file you're currently reading, find model GE MPSG and do the declarations for that. And then I'm going to say, okay, now I want to solve it. So I say GE iterlim is equal to 0. So that's the whole thing right there. And the .gen file is the thing that passes the data from GAMS to MPSG. And then when you say solve, then GAMS goes and solves it, and it goes back and all the variables get pulled back into GAMS. So the gen file is the thing that's a little bit different in the sense that you have to basically take a step that says, okay, move the data out to MPSG so it knows what it is we're trying to solve. And that should be the whole thing. And if I go down below, let's just copy this stuff. Solve GE. So there's the GE model. So I'm just going to put it here. Let's just see here. Does somebody have a hand up or there?
Yeah, I had a question. Would you
Okay.
mind repeating the difference again between Q, D, and E, just to make sure I'm understanding everything?
So the Q and P. Okay. So is that the question? Or maybe I make sure I understand. So we have.
I guess, yeah, all of them, Q, D, E, and P, if you could just repeat.
Okay. So in a demand block, there are two types of records. One is an endowment record, and the other is a demand record. To describe a consumer in a general equilibrium model, we need to know what are their preferences and what are their endowments. The thing that's funny here about MPSG is the way we describe preferences is not through some abstract utility function. It's much more concrete. We say, we observe what do they do, and we write down a point on their indifference curve. So that maybe I should I'll stop sharing. I'll go to the
Go to the whiteboard.
yeah, go to the whiteboard. So
Can you read what you're writing from? Because it's not very well visible.
Yeah, it's not clear enough really to see from our end.
So here I'm just writing down the MPSG model, what the entries are, and this has got, is that better?
A bit better.
So
Yeah,
you've
it's a
got-
little bit better.
So this is saying I have a demand block for a representative agent. I have an elasticity term S, which is the elasticity of substitution at that point. That's given at the top. And I give here what is the demand for X at a reference point, what's the demand for Y, and what are the prices at which it makes that demand. And what that tells us is if we have a choice model, we've got X and Y. We have a point here, which is X bar. We have a point here that's Y bar. We have a slope, which is PX bar divided by PY bar.
It's worse than yesterday. Yeah, it is worse.
What's that?
The picture is blurry. It's much worse than yesterday.
Can you hit, maybe when you can hit, ask it to,
I can try it again. No, it's better. Okay.
Yeah, that's great.
so we have a slope. So this is just getting back to the fundamentals of CES functions, is that the whole point is that we can define a CES function by picking a point on the indifference curve, telling me, you give me a point on the indifference curve, you tell me what the slope is at that point, what's the marginal rate of substitution. So we have a point telling you what's the quantity of X, what's the quantity of Y, what's the slope, and then tell me what the elasticity of substitution is. I can then write down the functional form from there. So I then here. So that's the way MPSG describes the thing, is by what's the reference point, what's the slope there, what's the elasticity. So that gives me then the same, and this is just a way, and the whole thing is that then MPSG in the background, we tell it the point and so forth. It in the background is going to write down all the market clearance conditions, it write down the zero profit condition, it handles everything from here.
And I don't know if you missed it or you said it, but in the MPSG, only formula, only demand equation is called Douglas, right?
No, this elasticity, if I put this elasticity equal to 1, then it's called Douglas. Otherwise, if I put it equal to say 0.2, then it's going to look like this. So that's going to be, this would be sigma is less than 1, this is equal to 1, this is going to be sigma greater than 1.
Okay, so actually it solves in other.
Yeah, it takes any CS elasticity you want.
Okay, I think that's, yeah, then it's not just called Douglas.
It's going to be more complicated than that because we can create a nest, we can put nesting on it as well. So you'll see it gets, so you can do it. Anytime you get a functional form that has multiple layers and there's nesting, then it can get, the algebra gets messy. And that's the reason I try in the algebraic models, I try to use these macros to represent demand functions, because then that hides all the algebra, the messy algebra gets hidden. In MPSG, it gets completely hidden entirely. You don't see it at all. So that's the basic logic. So that gives me this guy. And then if I say then, say, sure. Is there another question from the chat?
No. Sorry, is my hand still up?
That's fine.
No, it's gone.
Thank you. No, that helped clarify.
Okay, so that's, and I'm just trying to do is to point out that what you've learned, you've seen already is essentially, you've already know how to use MPSG because you're writing models down that are essentially, so if I just do this exercise, Q3.
This little explanation you just did, sorry, but that's on the website too, right?
Yeah, yeah.
Use your Ann Arbor example for it.
Yeah, you could do the Ann Arbor example here as well.
Yeah, okay.
So
I'm
this
just
stuff,
making sure that that's what you were going over.
yeah, so it's the same idea. I mean, yesterday we talked about CS functions, and MPSG is really all about CS functions. It's really not.
It's all just underlying.
Yeah, it's
right?
all, and it also, the thing with MPSG is that you write it down, it's always going to get the function right, and it always gets the equations right.
Mhm.
Right? When you do it yourself, you better be careful that you get all the equations written in properly.
Mhm.
Right?
Yeah. You're talking about when you do what we've been doing this entire week.
That's right.
But MPSG allows you to just focus on this basically code and not worry about the functions.
Right.
I mean, I meant actually CES, not called Douglas, my question when I was asking. So I said like, it only has called Douglas, I meant to say CES.
Yeah, so the thing is that one of the new version I'm actually working actively now, it's like it's never too soon to come out with version 2 of software, right? So here we are like 40 years later. So I'm actually actively working on version 2.
And it will have other.
It'll have logit.
Oh, okay.
So it'll have the same, and nothing will change in the model. You simply switch the functional form. And that's the reason the logit stuff I was bragging about a few days ago with these, is that the logit's cool because it actually can calibrate to the same data as you have for the CS, and it'll give you different results. And I like that because then they're both locally identical. So for small shocks, they'll be the same, but for large shocks, then you'll be able to assess what they are. And what makes it cool is that it all handles, all the logit conversion, everything handles in the background. So any existing code, you should be able to just flick the switch and say, tell me what the answers are with this other functional form. I really like, I think this is cool.
This is the next thing.
Yeah. So that's what I'm currently working on. But right now, it just only works in CES. But what it gives you is the ability to make more, you can do more complicated models more easily here. So you can basically change the nesting of the function. There's lots of stuff that's better, but let's go on to doing the next one. Let's keep going. So there's exercise 1. Let's look at Q4.
We did Q4 yesterday.
I know, I'm just going to say, okay, so
He
there,
just wants to do them.
the Q4 we don't know. That's
Okay, sure.
Q5. Then okay, Q5 is here. So there's Q5. So let's just 2x2 .mpsg. So now we're going to say, oh, this is the one I did yet last night. Okay, so this is the one we had yesterday. So I'll just go through what the algebraic answer is, and then we'll write it down in MPSG. So here is here's Q5 involves, we want to separate capital into 2 factors, 1 for each sector. So we have sector specific capital. And so that gives us the shares. Recode M3-4 to this data and recode this model to allow capital to move between the sectors. So there's the data going in, and we have these shares of X and shares of Y. And then we declare the non-negative variables for the model, commodity, the activity levels, prices, zero profit, market clearance, income balance. We define the compensated demand functions, or the uncompensated demand function. That's the final demand, which is it's a fixed income share. So it's called Douglas, so it's a fixed share. And then we have compensated demand functions on the inputs. And here it's easier again with CES. It's better to define first what's the cost index, the CES cost, or the CS or Douglas cost index, and then write down the model that way. And then I have the zero profit conditions and market clearance conditions. So the zero profit says the value of the labor input per unit plus the value of the capital input per unit has to be equal to what the value of the output is. So that's simply the zero profit. And then we have market clearances. We have market clearance for X, for Y, for labor, for X sector capital, and for Y sector capital. And then we have consumption, which is the income level. And so write down the model. And now let's write down this same model using NPSG. So I'll say on text model. It's going to be NPSG. This is going to be GE 2x2. Just call it like that. We'll say sectors X. So X sector. That's an index, a Y sector activity index. It's not the output level, it's the index. And we'll say commodities. PX is the price of X. Price of Y. PL is the wage rate. Well, maybe I should grab the names, the variable. If I use the same description, then GAMS won't complain. So it goes like this. I just have to put the bangs in. Those guys, and then we have these two guys here, activity level for these guys. And then we have consumer. So the key difference here is that here in the MPSG world, we not only clear the variable as non-negative, but we have categorized them. So we say what each one is, right? And that's also, I regard this as good. I like to be on a short leash. I like it to actually, I like to be able to tell it and have it. I anticipate, I know I make mistakes, and I like to giving information helps it keep track of what I'm doing right or wrong. So I'll say here, then I'm going to say production blocks. We hadn't seen that yet. For X, elasticity of substitution is 1. If I go back, it's going to say, what are the inputs here? It's going to be output. The reference point is output PX. The quantity is 100. Input PL, the quantity is 25. Reference price is 1. Input is going to be PKX. Quantity is going to be 75. Price is 1.
And this is coming from the formula below.
Yeah, I'm just looking at the Cobb-Douglas demand function. And so the formula is just a way to automatically generate those guys. Prod colon Y S1. And now this is the same thing, except I'm just copy this and write Y. And this guy's going to be 25. This guy's 75. Demand it's called cons, and it's going to be demand for, now what do we have? Demand for PX, and that's going to be SHX times 100. Oh no, 200. S is gonna be 1. So at a price of 1, demand for PY, quantity times 200, price of 1. Endowment of PL, quantity is gonna be 100. Endowment of PKX, quantity would be 75. Endowment of PKY, quantity of 25. And again, I have to refer back to the variable, to the name of the model. I'm going to say GE 2x2. So here I'm going to say off text.
So the demand is for price for X.
Yeah, so we have a demand for X for the good that has a price of PX.
Okay.
So we don't say demand X, we say demand PX because we
Yeah.
refer, demand comes out of a market and the way we identify a market is what's the price.
Okay. So it is not price times X, it's just price of X.
Price of X, yeah, that's the variable. PX is the symbol that represents the price of X.
Okay.
So the thing is the demand block D colon must be followed by a commodity. If I put in, so, okay, so if I say that, then if I go here, so say GE 2x2 dot iterlim is equal to 0.
Can you do me one favor though? Can you scroll up? I don't understand. So keep going up a little more. How does it know down in, right? Because if you run this, you'll get the same answer as all the
Yeah.
algebra. But scroll, okay, so go back to demand. How does it know what HX is? You never told it anything about that.
No, but that's a parameter in when we can write out, we're using parameters from the GAMS program that it's sitting in. So I can, any of these guys, right now I have a simple model, so I have numeric values, but the whole point of this is that we have the GAMS code with all the data and we can make references. This is a link between the GAMS program and the MPSG
Okay,
model.
but you would need to, all those parameters in this model. So say you weren't gonna, you're talking, okay, let me just make sure I understand. The GAMS program, you still need some of that,
Oh, you need all of it, yeah.
but you don't need all the algebra.
You don't need the algebra.
Yeah,
You don't need the
all
equations.
Equations and all that, exactly, but you need all the variables and the parameters and all that, right?
You need the parameters. The variables will get declared automatically, so we don't have
That's
to.
those up here,
Yeah, those guys.
Okay,
And if you have an MPSG model, even if we don't have the MCP model beforehand, where we can still write the MPSG model, it will do the declaration. So let's look at how this
well,
works.
so yeah, what I'm trying to say is, if you were to write this clean with no MCP model, you would have to put the parameters at the top here.
Yes, because you need the data.
Yeah, exactly.
So
Okay,
I-
that's where I was getting
So
confused.
let's just clear it. So there are the parameters
Yeah,
and say,
which there's my SHX, so I'm happy now. Satisfied.
so now I'm going to put the MPSG. So assist include, so include.
So you need the sets and parameters, but not the variables.
Okay, yeah, that makes sense.
So let's just look at, let's just run it to this
You're gonna
point.
do a clean run without anything else.
That's right. So there's the clean run.
Okay,
Now let me just do something to help you see how this works. This is
Okay.
like behind the scenes.
yeah,
This is the sort of stuff that many people use MPSG and they never take the time to actually try to understand what's happening. But MPSG is very valuable for large models because the diagnostics is better. So if I say GAMS, I'm going to do a trick here. I'm going to say, instead of GAMS, I'm going to say GAMS keep. GAMS keep is a syntax that says run GAMS and keep all the temporary files. So all I'm doing is just a replication. Let's have a look to see what happens with this guy. So if I go into my listing file, there's the listing. So in the listing file, there's the model declaration. There's the parameters. And here now I have the comment block that has the model.
yeah,
And now I have the MPSG preprocessor. Now here, this is MPSG talking to me saying, okay, I'm reading the model. This is what I'm reading. That tells me the line numbers for what it gets read. It gives me a cross listing and there's no symbols here, so I don't have any, it doesn't, nothing is, all these things are raw numbers. Doesn't get to see any parameters, so it's not telling me, there's no symbols that it has to report. Oh, no, I'm sorry, but here it's going to say the symbols we have here in the MPSG model include cons, which gets referenced on line 14 and 26. PKX is a price, which gets referenced on 10, 19, and 30. It has PKY,
I see, it's just telling you what.
where the thing, and then it says, okay, now, but nothing else gets hidden. So the generator file, but now let's look behind the scenes at what is this guy actually generating. First thing is GAMS CGE.dat. There's the data file that gets passed to MPSG with all the numbers, which in this case is just a repeat of almost of what we did. But then if we look at GEH, this is the stuff that gets written by the MPSG processor. It says, okay, I'm going to generate a file. I'm keeping track of these guys. I'm going to declare these variables. I'm going to put together a dummy equation that passes all the variables from the model over. I'm going to give you initial default variables, and I'm going to put the dummy equation into a model called GE2x. So this is all getting happen in the background. It's creating a model for you. It pushes all the variables through the model. So it creates, and the model, GAMS just thinks the model is just this dummy equation, but in fact, that the dummy equation passes all the variables through, and then MPSG reads the data file and then hands it back, right?
You wrote all that?
Oh yeah, this is 1980. This was my,
Yeah, I know.
yeah, this is all written by. So that's what gets generated. And then if we look at the .gen file. Okay, so what happens with it when I say include GE2x2.gen? This is the gen file. It says, here I'm going to generate your model. Okay, fine. Turn off the listing file. Don't show the user what I'm doing. Put into the MPSG file $model, and now I just dump out all the data from the parameters, and then I set the model up. I make sure I have the current version, then I off and running. So this is what generates the intermediate input file. So it's all, now the thing is, this, in this little example, it may not be so obvious, but in fact, if we go to the, let's just see if I may. So if I say GTAP model, clear, GAMS keep GTAP model. There's the GTAP model. So the thing is, now I have I have the data file. So now let's look at what we're generating. So if I look at so here's the GTAP model. A lot more complicated. It's referring to sets. It has lots of parameters that get exposed. So we see in the Q fields, I have all these VOMs, then there's a set, and I have a bunch of exceptions. The exception says only generate this production block if VOM is not 0. This guy I'm looking right here.
Oh, I see. That's what.
So it generates it if not 0. We have a nested function. We have lots of different elasticities going on. We have reference prices. We have lots going on. So you say, oh, I want to know what it is I just generated from here. If I go in here.
When you say this is the GTAP model, this is your replication of what GTAP's doing in GAMS,
Yeah.
or in
MPSG.
MPSG.
So let me just,
You wanted to say MS. But I got it.
so then this is the model that gets generated. So here you can see all the numbers in the GTAP model.
Mhm.
Every single input that goes in is evidence. So the thing is, for a large model, the cool thing about MPSG is I can see exactly what the data are at the scalar level. And so I can interrupt the thing. Anyway, that gives you, it's a little bit overwhelming, I realize, but it's like,
I mean, it's overwhelming just because, I've done it, but like, I see what you're saying. You can go and see all the data.
you can see
pulled
every
in.
single, you can
Input,
see every
output.
single number that gets generated.
Yeah.
So that's a really big advantage. You can see precisely where.
So
stuff is.
how calibrated is this to the actual GTAP model? Have you tested that?
Yeah, they give us the same numbers.
Oh, it gives the same numbers.
Yeah.
Okay.
I mean, the thing is, there are certain ways that we can cut some corners. We don't include, this version uses Cobb-Douglas demand rather than CDE, but we have done tests where we get exactly the same number.
Same, okay.
So you can formulate, there's a version of this that's exactly the same. But let me go back now to, let's go back and finish off this little example. So it's like, so there's the example in MPSG, and that just, and then at that point, this is Q5. And then it goes forward, and now I have the same model. Same model in GAMS MCP. Right, so that, and then it has all the demands, everything's there. And then this guy, so let's look at what we have. So that we said counterfactual 1 was recode the model to a specific factor. So we have specific capital. So I've coded the model right. Instead of having just labor and capital, I have labor, capital for X, capital for Y. And then it says exercise 2 is to recode this model to allow capital to move between sectors. So if I look at this algebraically, I have KXY is going to be the movement of capital from X to Y. And KYX is the movement of capital from sector Y to X. So this is Jim's, in Jim's example, his assignment said, he says, okay, put in these 2 activities to make it go. So now I have to write down 0 profit conditions, and I have to revise the market clearance conditions for capital. So here I have the 0 profit condition then says that for KX to Y says the cost of moving capital for X to Y is we have to buy a unit of capital in the X sector. And the revenue is, so it says this activity is going to be associated with a profit condition as PKX has to be greater or equal to PKY. And likewise, PKYX, that says we buy a unit of capital from Y and we produce a unit of capital for X. And then finally, if we have the market clearance condition says, well, with the endowment of X sector capital plus the amount of capital that comes from Y into X, and that's got to be equal to the use of capital in the X sector plus the amount of capital that gets moved from the X to the Y sector. So that's just, I'm just putting those 2 guys in, and that goes like that. Now, if I go back and I say, okay, so on text, let's just do this at the bottom of the model. Two. So then I'm going to have K. I just declare these guys as activities. Nothing else changes. Nothing has to change here because we don't have to rewrite the 0 profit condition order because it's going to generate. So this is KXY, output of PKY, quantity 1, input of PKX, quantity 1. KYX, output of PKX, quantity 1, input of PKY, quantity 1. Done.
Yeah.
So you have to we don't have to declare a new equation because that's all handled in the model.
Yeah.
It will automatically, MPSG will create the markets that you need to do. And that's, so this guy is going to be, this is GE. So I just have to change the name of the model. Dash Q4. Make mistakes. X back to 1. So reset to return to the default value. Notice that there I did a counterfactual, so the level values will be, when I solve the HO with K and Dow, I get a number that will not be the benchmark, but I don't need to reassign the values because MPSG, when I generate this model in the MPSG thing, it'll automatically assign everything to 1. So MPSG assumes that you're using a Harburger normalization with all the prices are from 1. So that gives us our second example. I'm just going to do one more here.
Now let's let's go to Windows C. Is
Okay,
that cool?
that's fine.
Yeah.
So now you can see
I
what,
think like this was sufficient for,
yeah, I mean, it's just, all I'm just saying is that the MPSG format, the main thing is it gives you, you don't have to write down the compensated demand function, so there's a lot less places where you can make mistakes on the algebra. And then it automatically keeps track. If you create an activity that moves stuff, it automatically generates that stuff for you. Okay,
Yep, no, that was perfect. I think we got some stuff to chew on now that we have
Yeah.
those exercises.
once, the thing about MPSG, it's always a bit of a it's a steep learning curve. But once you get into that domain, you don't want to go back to writing algebra.
Yeah.
So there's this problem that the algebra is so much harder and there's so many more places where you can make mistakes. So the MPSG thing is a huge advantage.
Yeah.
Maybe we take, why don't I wait for 4 minutes? Just, okay.
Yeah, let's do that.
Let's take a break for 4 minutes, 5 minutes.
Yeah, I'll leave it on.
Yeah,
We'll leave
just-
everything
just gonna
running,
leave it
but-
on. I got that too, actually, so that's helpful to me. But yeah, let's.
Hmm.
You can turn off your video for now.
Oh, yeah. on, I'm gonna unmute.
Yeah, you're back.
Okay, so now I'm gonna say, okay, so clear this guy.
And can you all hear us in DC? Just double check.
Yep.
Okay, thanks. Perfect, thanks.
So I'm now looking at the GTAP WinDC framework. So we're gonna get now to look at the model. And the idea here is to try to let's get our ideas straight about how the build works first to see where the data comes from. And so we look at run.gms. That's just my script that runs things. So we verify that our first thing is we say, okay, let's verify that we have a GTAP model. And this says GAMS GTAP model. It's very similar to our energy model in the sense it's just a declaration of the model and a solve that gives you a handshake on the data.
Okay.
Right, so it says GAMS GTAP model, simply verify I've got a handshake on the data at that point. So the data set I want to work with is WinDC7, which is a 7-region aggregation of GTAP data set. If we look at what we've got, the GAMS data, GTAP 10A, there's WinDC7. So WinDC7 involves 7 regions, the WinDC sectors and all factors. So if I look at what the GMS, so if I look at WinDC7, I'm sorry, then it says the 7 regions are US, Europe, Canada, Mexico, other OECD, China, Hong Kong, rest of the world. That's just the way I defined it. And here I have this again, we're going to talk about, we'll be going back to doing this, but this is the way in GAMS you define an aggregation. So we're going to say define from the sets UR is a universal, just a free, it's a wild card, a bunch of labels that come from the GTAP world. So each of the regions in the GTAP world, I'd say what region the aggregate data set this goes into. So this says
I see. You're just-
Argentina goes into ROW, Brazil goes into ROW, Paraguay goes into ROW, and so forth.
Yeah.
Canada goes into Canada, and then there's the ones going and so forth. USA goes
And
into
you put them
USA.
into these regions up above, right?
Yeah. So the ones that are separate are going to be these 3. And the order doesn't matter. So that gives you all these guys. So that gets the set USA, Europe is separate, and China. So, and China involves these guys. There's different ways you can, this is what's known in GAMS as a tuple, which involves a pair. And there are different ways you can do tuples. Here's a fancy way where I have a comment. The bang represents a comment at the end of the line, so that gets stripped off. And this has China and Hong Kong aggregating to China, but that's just sort of details. If I look at the other, so this is just, and we could do this with more regions. We just have to go back to the GTAP data set and say we want a model that has other regions in it.
Mhm.
And that's the whole thing about GTAP is you have lots and lots of regions, but when you, particularly at the beginning of an analysis, you want to trim it down to the minimal number you need for your study, and then you can it's a sensitivity analysis to see what happens if we add more, but initially you just want it to be sort of a minimal level. And then if I look at the other sets, we have the WinDC sectors, and this involves individual sectors. I put in uppercase the set elements that come directly from GTAP. So those are things that are from the GTAP 10 concordance. And then the lowercase ones are ones that are aggregated
In GAMS,
in in GTAP.
in GTAP.
So the thing is that we have a whole set of sectors in GTAP. We have a bunch of sectors in WinDC. Many of them map 1-to-1,
Okay.
but some of them don't. So there's some GTAP sectors that have no corresponding sector in WinDC. And there's some sectors in WinDC that have no corresponding sector. And so we do is I boil those guys down to, I have to aggregate GTAP and aggregate WinDC, so we have a crosswalk 1-to-1.
Okay, and they are at the lowercase.
So that's the lowercase one. So agriculture in WinDC, we just have one agricultural sector. GTAP is set up for agriculture, so it's got lots of agricultural sectors. So we had to aggregate the GTAP database to have one. I want to begin by having 2 versions of data set that have the same commodity classifications.
And we have the NAICS codes next to them.
Yes. So I have, yeah, and depending on how careful you are, there's some that are not as well specified. You can go, there's concordance lists. I can always dig up, all that stuff is available on the website. And this is one of these things that's this thing of identifying what's the NAICS code for this and how does it classify. And it may be that I didn't do this perfectly. It's like, okay, there may be some that has to be double checked, but for the most part, it looks okay.
This makes sense. So all the ones below, they tie out.
They tie out.
Okay, yeah, that makes sense.
And then the other ones we have to aggregate depending on who's one. So,
Yeah.
for example, much more aggregate agriculture in Windy Sea, much less in their food, forestry, and fishing get combined. Whereas in the other one, it's separate. We have food, beverages, and tobacco. I think that Windy Sea has, anyway, I'm not sure which one, but that gives you the list of what's there. So, and there's the mapping. So we can see how these guys get mapped. So the agriculture, this is the mapping of the GTAP sectors to Windy Sea. So these are the ones from GTAP that go to Windy Sea. All right, and we have, for example, in GTAP, we have wearing apparel and leather products are separate, and in Windy Sea, they're the same. And one of the ones that's a major challenge is iron and steel and non-ferrous metals are combined in Windy Sea. So there's, there's work to do. This thing about, identifying, getting down to the sector you want, your life is a lot easier if your analysis relates to something you already have data lined up for. Life is good. If it's different, then you have to work a little bit to get the thing disaggregated. So there's always this process. And the rest are one-to-one. If I look then the factors, so this one has all factors: managers, technicians, clerks, service and market sales workers, agricultural labor, agricultural and other unskilled labor, capital, land, and natural resources. So that's going to be different than Windy Sea. And I may not have, I would ultimately, we have access to the BLS labor services, and I have worked with getting those reconciled to Windy Sea, but they're not in the current build stream. So that's on my list of stuff I want to go back and make sure I do, because we should be able to have the occupational categories in the US data are more detailed. They don't tell you anywhere which household owns which labor type, but richer households should be in higher categories. And so there's a way of identifying that. So anyway, so that's the GTAP framework. And let's now look. So what I have here is I have GTAP. I have then, let's just get rid of this stuff. I'm going to get rid of the list files for now. Get rid of the gen files for now. So I've got GTAP. So I've got GTAP data, and that's typically the way I work with these data sets. I usually just write one code that reads all the data for a given data set. So then you just pass it a data set name, it knows what the data set is and goes to get it. If we go to the GTAP data set, it says, okay, what data set are we looking for? That by default, it thinks it's looking for Windy Sea. It thinks it's looking for 2014. It thinks the version of the GTAP data set that we're working with is 10A. I've set this up so that now my GTAP connection, you can pick any version, any of the years for which they have data. And so I have a very flexible thing where you can test this. You can basically change the data set and automatically it'll go. And so at the hot level, you say, well, what data set from what year? And it'll go and get that one. And when it goes to get it, it says, okay, so there's a little complication there about reading what are the goods, what are the factors. So it says here, what are the sluggish factors, what are the mobile factors? There's all the stuff. We have some data that has to do with anti-dumping. So we have some data on tax structure, on how much is anti-dumping duties, what's their export taxes. These are things that are just additional data you get with GTAP. And then here are the core parameters that you get. And one of the things that's a bit of a subtlety in the GTAP and GAMS formulation, I always work with a minimal data set. In other words, I don't have duplication of the numbers on the file. It's just the file, I have the minimal number of things. Whereas in the GTAP approach, they throw the same data will appear in the data file in multiple different formats. They'll keep net and gross. Whereas for example, I always keep the net of tax value and what the tax rates are. And then if I need the gross thing, I just multiply the tax rates times the thing. Whereas they keep lots of stuff. So I just basically for my own sanity, I like things to be tight. I like it to be like, this is the minimal file we need. So here's the population, energy trade values, energy use. This is all stuff from GTAP. We have the tax rates, RTO, output taxes, value added factor taxes, taxes on domestic flows, taxes on imported flows, subsidy rates, and so forth. And then you have a bunch of elasticities, which are by sector. And then we have these other things for the CDE demand system. There's a little bit more information. And this is all documented in our implementation of this. I mean, of course, for GTAP, you can find lots of information, but if you go to get information on GTAP and GAMS, you can say Rutherford and Lance. It's GTAP and GAMS. So if we look at this, so this is the paper we did. Oh, that's a conference paper. We also have, it's also been JGEA. Why does that not show up?
Oh, below it.
Yeah, so here's the paper. So here you get the paper. And there's a whole bunch, and the paper is free. And then there's supplementary files that has all of the GAMS code for it, right? So there's lots of, so all the stuff I'm showing you is stuff that's documented in the paper. Is nice and clean. It basically goes through what the format. It's actually got a lot. There's a lot in this paper. We did it right. I basically downloaded all the stuff I'd done with GTAP over the years into one paper. So it has more than it needs to have, but it's got. So that's the GTAP data set. So if I go back, so if we're working on the GTAP WinDC connection, what's the first thing we want to do is I want to verify and run. I want to verify, do I have the GTAP data model held? Have I got the GTAP model in my hands, right? So I say, okay, first let's go and solve that. So I say GAMS GTAP model, and that goes, reads the data, formulates the model. I can see I have a precision of 10 to the minus fourth. Close, good enough for government work, which is actually an expression that has the exactly opposite meaning to what it had when it was created. Good enough for government work was an expression used during the Civil War. And so if you were making something or making clothing or doing something to spec and you're doing it for the Union Army, to do it good enough for government work meant that you had to do a really good job, because they would, if you did a lousy job, they wouldn't pay you, right? So it was like, that was, now it means, okay, good enough for government work means do a crappy job. 10 to the minus fourth, this is a data set that has numbers in the order of 10 to the fourth or fifth, because it's in billions of dollars. So therefore that's about 8 orders of, that's a reasonably precise data set. Now, if I look at my model, let's just look at the model. See if I can copy this guy. So if I look at, let's just look at the MPSG model. So here's the model. We have production of goods by regions. We have imports, and G includes all of the produced goods and services, as well as consumption, investment, and public expenditure. So G has got, it's an activity that includes, I've mapped the production of final consumption is mapped onto that. That avoids having to have I reduced the number of elasticities I need to float around with. And then I have imports, and that's again a difference from in the GTAP model. They have separate activities for consumption, one for public consumption, one for investment. I just want to minimize the footprint of the data set, so I just have one type. Import by commodity and service. File transformation allocates specific factors, certain types of capital are specific to the sector in which it's used. And we have aggregate transportation activities for international trade. And then there's the markets. So the key thing here is that the representative agent, there's one per region. So we have one per region. When we go to GTAP MGE, or we go to GTAP WinDC, that's going to change. Because if we're going to have that in the US region in the model, we'll have demand by country US, by state, and by household.
And that household is for each state disaggregated?
In WinDC, we have 5 quintiles in each state.
Okay,
So we have a total of 250 households in WinDC
and how they are categorized?
in quintiles.
Okay.
I
Okay.
mean, and
Yeah, and we have 2 methods for doing that assignment. That was our main work this year, was disaggregating that. And we have methods going from the statement of income, the SOI data from IRS, or from the CPS. So we have 2 methods, and we've written we're in the process of writing up the final paper on that, but you can find lots of discussion about that. There are slides on the website about how we do this. So let's look at the WinDC model.
New York is not saying it on the phone.
yeah, I think he's saying, right, because you said
So
250, so each state has
5.
5.
Yeah.
Yeah.
There's 5 different.
So this is the WinDC model.
What she's asking is, does each state have different numbers in those points? So it's.
Yeah.
yeah,
Yeah,
that's what I-
Yeah.
yeah,
Okay,
yes. So, yeah.
They
exactly.
different in terms of what their endowments and preferences.
Yeah.
It's all characterized, right? So that's all. This is, we actually have work from data that has a survey that works by household, by state. So
okay.
that's, let's see if I can point you where this is on the. It's
You mean on our website?
yeah,
She can download the
Yeah, I can definitely look at it.
on
later.
downloads from.
no, but I'm saying, is there the slides,
Which slides?
presentations,
I see
discounting
it's the
consumer
second
house
one.
by income
Yeah.
groups. So
Okay.
there's a set of slides that describe everything of what we're
You
doing.
can
Right?
maybe put this to one time.
This
Yeah, on the course. So that
on the
we-
course website for
Yeah.
Friday.
So this has lots of stuff talking about how we did
Or I
it.
can find it.
It's,
Yeah, okay.
Just let me know what you want, and I'd be happy to.
So I'm not saying it's perfect, but we're very open about what we did and how this works. So the thing is, you get data that's about as good as you can get. Our whole idea is that there's lots of different places that produce economic data for the US. We're trying to take stock of what there is and write in an open source manner a set of code that grabs that data and puts together into a coherent bottom line.
Mhm.
Right? So if you want to do a model and you want to rely on these different sources and you want it to be consistent, let's go and get it. And we don't want to be the ones that we don't want it to be our data set. We just want to provide you with the tools so that you can go and get it. And so your choice to use WinDC is a decision to take responsibility for looking at the build stream and making decisions about how do you want to treat that data, right? We make the point that you can use the CPS or you can use the SOI. We give you a choice of which data set you want to use. And furthermore, you can go into the build stream, and if you don't like the way we've calibrated to the demand for services, then you can do your own calibration. Right? So this is all there. But this is pretty well documented how this works.
Okay.
So now I'm looking at the WinDC model. So I have the GTAP model out there, countries. R in the GTAP model is countries. R in the WinDC model is states. Or you can aggregate it to be census blocks or whatever. So you could aggregate it differently, but right, the most disaggregated versions are states. And in this data set, there's activity within each state, but there's also labor supply by state, by household classification. And I look at final demand, we have a representative agent by state and by household classification. So we have quintile demand by state. We have the New York Stock Exchange, which we assume that capital is commonly held. In other words, it's not all the capital. It's not as though there are certain capital stocks in Wisconsin which are owned by Wisconsin firms and households, but there are other ones where lots of Wisconsin people own capital across the whole country. So we have an activity that that owns the capital ownership across the whole country. We have an aggregate investor and we have an aggregate government. So that's and then we have a savings rate, and we have, so this describes the WinDC model. And again, it's got a lot of stuff that's similar, like production involves labor and capital and intermediate demand and produces output. And we have, but one of the things that's different here is that when we buy output, so this has got a make matrix. So YS0 says region, state R, sector S produces good G. So there could be multiple goods that get produced. And then good in state R, good G gets combined, and some of the goods get sold in that state. Other ones get sold in the national market to other states, and other ones get exported.
That makes sense.
Okay, so the thing is, the stuff gets allocated. So and again, in the MPSG world, there's a transformational elasticity that describes how relative prices of those different markets determines where stuff gets allocated, where it gets passed. Okay, so that's the transformational elasticity here is 4. And then we have on the demand side, when we're buying goods, we may buy some imports. That's through foreign exchange, and then we may have a margin on that applies, and then we buy from the state market. We may buy from the national market, and then some of the goods that we get imported gets re-exported, and then this is the supply goes into absorption, and then absorption goes into intermediate demand and final demand. So that's basically describing. So there's more details here. You know, we've come a long way this week. I apologize that we haven't worked enough with indexed models that this is immediately obvious how all this works. You know, there's this process of how to work get a data set in Excel and then move it into an operational model. It's not, conceptually, it's not any different than Markson's little examples, but there's just a lot of machinery for keeping track of the sets and so forth. But the key thing in terms of understanding how the WinDC GTAP connection works is that here in WinDC, we have demand by state and by household. And so we have different compositions of consumption, and we have the mapping of what goods get consumed differ by state, the composition of how much is labor income, how much is capital, how much capital they own. All those things are calibrated and they differ by state. So now if I go to run.gms, what are we going to do? We first say, okay, well, let's first we're going to build a model which is like GTAP, but in that model, we're going to have subregions and we're going to have households.
Mhm.
So the first thing I want to do is I want to build what I call a stub model. So that's where I say, and let's first just look at the stub model. Let's look at where we're going. And here I've lost this guy. So I'm going to say GTAP WinDC model. So this is the model we want to generate. And I could write this model down without having the data. I'm just writing down the logic of how the model works. So this is going to be production by good, or by, and that's including final demand categories, by country R. And then I put in a symbol called S, which is going to be a subregion. And then, so that involves the activities in subregions. And then we have consumption by region, by country, by subregion, and by household. So if we fully disaggregate here, we're going to pick up, and the idea here is that I want to formulate a model where I can have all the other countries have one subregion, that's their entirety, all of them, and one household. Only the US will have 50 subregions and 5 households per subregion. So that means that I will generate, I'm going to have an element of R or of S, which represents the rest of the country. And I'm going to have an element of H, which represents the rest of the households. So my first step here is to firstly say, I'm going to say, if I look at stub, I'm going to say write stub. So here I'm going to grab the GTAP data set, and I'm going to declare S underscore to be subregions. That's going to be rest for all of them. And then I have H of star, that's going to be households, and that's only rest. So now all I do now is I declare the same parameters I have in the GTAP database, except I put an underscore at them. So, and I add to them, in addition to R, I add S underscore. And then I basically say, okay, I'm going to pull all these data across. In other words, I'm going to move them, all the data from GTAP, I move into things that have this additional index. And then I unload that as the data set, which will be WinDC7 underscore stub.
I have one question. Can you show us the line that shows in US there will be, so it is not, in US we don't have S underscore.
No, the S underscore is simply because the symbol S is already used in the GTAP database. And so I had to put an underscore into it just because in the WinDC, GTAP WinDC model, S refers to subregions.
And I'm just trying to see which line here shows us that US has 50.
The thing is, when I create the subregions, the US only has a subregion as well.
Okay.
Here I don't do the disaggregation in the US first. I simply say, okay, produce an index version of GTAP data sets where all the countries just have one subregion and one household.
Okay.
But I can take this stub data set and I can run it through to verify that my WinDC my GTAP WinDC model can work. Because once I have this, let's just do this. If I say,
I think I saw.
this is where if I say GTAP WinDC model. If I say, seven underscore stub. GTAP WinDC, GTAP 7 stub. So let's just run this one. And then this I'm going to show you, I'm going to demonstrate, I'm going to say clear, and then I'm going to say GAMS keep. So I run, oh shit, something is fucked up. What did I do wrong here? Sorry, I'm sorry. Go away, please. I don't like the fact that when I use my editor,
Oh, yeah.
it's really annoying. Oh, I have to build this guy. So let me just go to run. Oh, 1 second. I just GAMS data. Oh, wait a minute. GTAP WinDC stub. Oh, 1 second. GAMS data. GTAP WinDC. Oh, I made the wrong name. Oh, that's the whole thing. It's like this is WinDC 7.
Oh, geez.
In DD, it became in DD.
I get nervous and then I screw up. Model. I still am screwing up.
That was a D. Did you see that one? In DD.
Oh, I'm sorry. This is in model. My mistake. I've been editing this guy. Then I screwed this up. I don't know what I did here. That's it. Where is it? Oh, I just have a comment. I have a comment there. This shouldn't be. Man, I screwed something up. There we go. So that's the model. So if I say this guy was, so I say GAMS clear. I'm just trying to explain one thing and I end up screwing myself up. So now I'm just going to run the model with the stub data set. I'm just trying to explain what we're doing. So, okay, so now if I go, so I've run the model, now I can go, the advantage here is now I can go into the big model, into the big data set. I say replace string. So now what are we doing here? So here we have, there's the production function for oil in China in rest of world. So if I look at what are the sectors that I have, I've got oil production in all of the regions, in my 7 regions, and they all have just a rest of country. So this model is the same as the GTAP model. It's just been relabeled to have this rest in there, right? And so that's all of them, just all it does is essentially add, but we has the structure. If I look at for demand, if I look at our households, consumers.
We won't have rest next to US.
No, the thing
US
is,
is
no,
different.
at this point, I've done it for all of them, including the US.
Oh.
So now once I have that, then if I go back up above, now I have a data set. But now what I want to do is, so once I've got that, and I've got the stub data, then I'm going to say, I have a thing called balance. This disaggregates regions for the US for 2014 based on WinDC benchmark. So what this guy does is you start off by reading the sets of subregions and households in the WinDC data set. Those are the subregions in the US, and there are the households in the US. And then I say, well, the subregions in the model will include the subregions I have in the US, as well as rest, and the households I have in the US, as well as rest. All the other countries in the data set will have this, will just have this representative agent, household, and rest of the economy.
Yeah, that's right.
In the US, I just grab whatever set is I've defined for us. I did it this way so that I don't always have to work with the US model that has all the states, because it's helpful doing the debugging work. It helps to work with a version that's got, say, census regions. So you only have 8. So it makes it smaller dimensional. So it goes around. And then I grab the GTAP WinDC data. And then here I read in the data set. And here I look at what is the trade export, and this is comparison of exports and imports in WinDC and GTAP. So that's the comparison between these guys. And now I'm going to write out a data set. So I'm going to write out variables that represent the data set for by good, region, and subregion and state. What are the values that go into the GTAP into the GTAP WinDC model? So that I declare variables. These are variables, not parameters, but I have variables for each of the parameters in the data set. So once I've written down the variables, then I can say, well, what did the data set have to, how do they have to aggregate up? So first of all, I have to choose values of these that are targeted to some target. And this is just a fancy way of writing down the targeting. And then I say, okay, well, I have to have 0 profit for the Y. I have to have 0 profit for X. I have to have 0 profit for Z. I have to have 0 profit for C. I have to have income balance for the household. I have to have income balance for the government. I have to have income balance for the investment activity. And I have to have market clearance. So I basically am writing down all the conditions that are imposed on the data that go into the model. So I'm saying, here are the equilibrium conditions that the model has to satisfy. I want to choose a data set which is as close as possible to what we see in the WinDC framework, but at the end of the day, I want it to be balanced.
I will be scared of all the typos and missing commas I'm going to have in my own model.
It's the thing is, this this is heavy lifting. I mean, there's a reason why there isn't not a data set around that has the states and it's just, it's tedious. It's not that it's complicated or it's not intellectually complicated, other than it's one of these activities, this process of disaggregation is the only thing you can do is make a mistake. You can't really do it right because everybody says, well, that's obvious, just take the target and do it. But in fact, there's so many ways to do it wrong that the main problem is nobody wants to do it because it just looks like you're stupid. I can't balance a data set. Why don't I just do it simple? No, it's harder than it realizes. My experience with this sort of thing is once you get it running, then you improve it. And it's really a matter of just how many months have you worked with the data set. As you work with the data set, you find something wrong. And the beauty of having the build stream, the reason I'm beginning with the build stream is I'm showing you this is where we're at. The thing works. I will be working with the data and the model, and I'll be finding stuff I didn't do right here, and I have to always go back and fix it, right? So that's the process. This process will be ongoing for the next few months. And part of the reason I want to do a project with this is I want to use the data set to do. I want to know if we put in climate policy with border measures, which households are helped and hurt in which states. How does it matter? That's my question, and that trying to answer that question will help guide me to what is wrong with the data set. And then I'll fix stuff, right, as we go along. And I have to go back to, so this is just a balancing process. We put in what our objectives are, and there's a bunch of GAMS coding stuff that are tricks that make it, in general, anytime you can do something where you reduce the number of characters in the GAMS code, it's good, like making it small. So here I use some macros to help me automate some stuff. And then here's the solving the balancing using quadratic programming. And then once I do that, I put in some new targets. And then I have to basically go over I'm saying I'm only going to balance the US, all the other regions, all the other GTAP data does not change. All that's happening is we adjust the WinDC targets to match the GTAP trade flows. And so we end up with a model which is as close to WinDC as we can, but satisfies all the equilibrium conditions of GAMS. So this is basically just, and this is something that's I'm not going to take the time to go through this line by line, but this is basically just pulling all the data, grabbing all the stuff, and then at the end of the day, we grab everything, we read the solution variables back, and we end up with a data set and we write it out. So that's DS out says, what data set did we generate? Push that data out. And this is just the inverse of the input operation. We output the sets, we output all of the, and this is all the data points that were in the stub. When we generated the stub data set, we did the same thing, but the stub data set, we didn't disaggregate anything, we just moved the data across. And now we're doing the same thing, except we're just disaggregating the US data and putting it out. So that's the whole idea is that what's the GTAP model? What's the WinDC model? Write a little stub that represents that where we have the sets that we need for the thing, and then grab some WinDC targets, use those targets to readjust the GTAP data set, and take the stub data, disaggregate the US, and put it out. That's all. That's what's doing. So at the end of the day, we end up with a model. If I look at this, let me just run. I'm just going to run to see how I run the thing. I just want to show you. So if we look at balance, and then this has all been done. So if I say here, for example, verify, label. Go to verify. Except I'm going to say GAMS, call GAMS keep. So I'm just going to, and now I'm just going to do the thing with the disaggregated model. So now it's a 5 megabyte data file. And here we have, for example, China and Canada only have a region called REST. In Y oil in the US, we have all these different states.
All the other countries just have rest. Yeah.
Yeah.
That's kind of like their state.
That's their one state.
Yeah.
Every country has one state.
Yeah.
In the US, we have one for every
That makes sense. So the stub is what you had to do that.
Yeah.
Right? You needed to create this basically US state within these countries and just make one of them. So that you could have even data, basically.
That's right. Everything else has got, it's mainly just in the resulting model, we have to index it. So we're keeping track of the subregion and the household. But the ones where we don't have that data, we just put it all into a singleton.
Yeah, I get it, into one REST household.
Yeah. So that's,
It just has to be, so you have the same amount of, I guess.
you need to have it indexed. You want to be able to write down the logic of the model that has everything indexed and be able to run it through to verify that okay, from my starting point, I've got GTAP moved over, everything is together. Now I simply operate on the US REST and split that out. And that's what the balance routine does, is basically splits that out according. So it goes and grabs the WinDC data at this stage is simply providing targets of what shares should be in which regions. And then once I've got that, then I have to write the code to rebalance it. And that's always the way it works in this, for this data set reconciliation. You always have this thing, I call it bending. You have to bend the data to match the totals. And then you have to, it's all just a matter of a needle in a haystack stuff. Is let's find where we made mistakes in terms of our targeting. So we have this process. So I generate huge pivot tables to look across what's happening across sectors to double check what's going
But I'm
on.
not sure I follow. So when you tie the US data to the GTAP data, that's why you have to rebalance, because they might not be equal.
Yeah, we show at the beginning, we say, okay, well, the imports and exports in WinDC are not the same
Yeah,
in
that's.
certain sectors.
uh-huh.
So we're not gonna, in the resulting data set, we're gonna have trade flows that exactly match GTAP, which means that something has to change within the US from the WinDC representation.
I see. And that's why you have to rebalance it with the shares.
Yeah, so we basically take the targets. The other thing about it is that the two models are not exactly the same structure. There's a slight different structure in GTAP than there is in WinDC. So there's not a one-to-one. I basically say, okay, well, if I'm looking at the GTAP thing, what are the value shares of intermediate demand? They're not exactly the same. So I basically say, for each one of the numbers that's in this thing, what would be a reasonable value for that based on what WinDC has? So I basically have I have to retarget the GTAP stuff to match what the shares are. When the data sets, the models don't have exactly the same structure. So we basically say, okay, in that balance routine, I have to basically take targets for what the value should be. So targets are, what are the intermediate demands for each sector? What is the labor? And one of the things we have to have is we don't have labor demand in detail. So we have to basically say, okay, well, take the labor shares we have in the GTAP structure. So there's all this stuff about like, what are some reasonable assumptions?
Assumptions, yeah, I see what you mean. We have to break it up.
We have to break the stuff out. But at the end of the day, we have to have a model where nothing else in GTAP changes other than stuff within the US. And that stuff gets bent to match.
So basically, if you ran this on GTAP under GMPeg in there, and then you ran this, everything else is the same except for the US is disaggregated now between the states.
That's right. And
So
we have to,
Mexico's gonna have the same results.
if you add up the state values, it might be slightly different than what you get for the US total in
And
GTAP.
that has something to do with these assumptions. You have to.
Yeah,
find the
because we're
same-
trying to match WinDC, and WinDC, I only looked for this handwise comparison, I looked at trade, but there also are probably differences in terms of capital value shares.
And
all
so
this
was
other
that
stuff.
what you were showing on the Tuesday meeting? You had run it. and
Yeah.
That was you were getting some differences.
So the thing is, the first thing to look at is the trade flows, and the next thing is to ask what else is different. And
But
that's,
that was what you were showing.
yeah,
Was, look, I'm not exactly even to what GTAP is.
yeah, it's not,
Because it's never gonna be like that.
Yeah. but we could take a scenario and run it in both of them without any trouble.
Yeah, the steel
Yeah.
one that Natalie mentioned, that is already done in GTAP.
Well, maybe we should run it right now. That would be useful to do. This is steel.
Can we do that?
We
Can
could do that.
it?
We
I
could do it.
mean,
What did he
That's
say
enough
yesterday?
time.
No sweat.
We have 15 minutes. I mean, the thing is, I always try to do more than I have time for. So the thing was, I ended up spending, the thing is, we're gonna come back at 1:30, right? But maybe what we should do is, we have a data set here. Why don't we just set up a little scenario file to run a model with the GTAP, a scenario with the GTAP model and a scenario with the WinDC GTAP model.
Uh-huh.
That will be immensely helpful,
Okay,
I think.
so that's what I'm saying. I mean, and that's consistent. I'm not expecting you guys to take stock of, all I'm trying to do is to show you how this works, since you have a general picture.
No, that's important.
No, I
So
think
like-
we should run one thing within these.
Okay, okay,
Like,
so,
it's either carbon adjustment.
okay, but that's gonna be
Or
more
the
complicated.
steel.
Let's look at the steel.
The steel, yeah,
I agree.
whatever is simpler for you
Yeah.
to do.
So if I
Yeah.
look here at what we got, let's first do it in the GTAP based model. GAMS data, GTAP 10A. Let's look at sectors, WinDC sectors. And this guy has got steel.
So you just need to.
Primary metals, or I guess it's primary
It
metals.
is primary metals, yeah.
Okay.
Yeah,
so let's look
primary.
at- so when I look at which regions we have, I'm just trying to take stock, the regions we have, primary metals from all countries.
Mhm.
So let's first put a 50% tariff on the US imports of primary metals from all
I mean,
countries.
or we could choose,
Yeah.
if you want, in a few countries, we could choose, China, Brazil, Japan, EU.
I don't want to disaggregate, I want to stick with these aggregations. So
Sounds good.
Mexico, Europe, and we could say so let's just go up here and we'll say,
Sounds good. We can try to replicate it with other countries later, if you show us how to do it with these.
Yeah,
Yeah.
and I can give you a more disaggregated model data set right now. So if I go here, I'm going to say GTAP steel.
What are you doing? Just naming something.
And I'm going to do the same technique I used for the energy model. I'm going to say include GTAP model,
Okay, so you're just pulling all that. I see.
and I'm going to say set DS WinDC 7.
That's the data set.
That's the data set.
Okay.
GTAP model. Let's first verify that that works. GAMS, GTAP steel,
You're just running this, right?
action equal
Yeah.
compile. That works fine. Okay, then we're going to say, if I look at the GTAP model, and I have the code, if we took the time to go back to my GTAP and GAMS thing, there's code for how to run scenarios. There's code for disaggregating GTAP. All the reporting stuff has been worked through and carefully. So I just have to go and get the code for doing the disaggregate, for doing the reporting. But I'm just going to do it quick and dirty now because that's
That's right.
okay.
No,
So
that's
now-
important.
I'm going to say RTMS of primary metals. So let's say S in the USA plus 0.25, 25%. So I'm going to say parameter, so it's tariffs, benchmark tariffs on PRM into the US.
Now just before you jump. Go ahead, finish your code, then I'll ask the question.
And let's look some other things. There's also an export subsidy. I just want to know what barriers are there, RTXS. And that gives me that stuff. Those are the two taxes that apply. And then I'm also going to look at VTWR, which is VTWR divided by VXMD. I just want to know what's the magnitude of the transport costs of J, I, PRM, S, USA divided by VXMD.
Can you explain the last line after you're done typing?
So the thing is, if I look at again, I'm looking at the MPSG model. If I import in the GTAP model, so let's look at these lines. We're going to produce a good called PM of I, R, which is the import composite of good I in region R.
Mhm.
That involves inputs of that same good that's been produced in all regions S. So VXMD represents the trade flow of good I from country S to country R. it faces a tax which is paid to a subsidy by the exporting country of RTXS. And then it faces a tariff on the gross of subsidy tax of RTMS. So that's the tariff. In addition, and this is a complicated piece of MPSG programming, it pulls in a bunch of transportation services. There's a transport cost, and PT of J is the price of transportation service J. That's a single market, international market, and that applies to each of the trading partners S. So we have a different, that transport cost J, PT of J applies to imports from all countries S. And VTWR of JISR is the transport services J, which apply to the import of good I from region R into region S. And when I want to know what the barriers are, I'm kind of curious, what's the export subsidy? What's the import tariff? What's the transport cost? That's just GTAP data. And I just want to double check what they are. Right.
Okay.
So and this oftentimes, when you're GAMS programming, this is oftentimes it works. You could go to Excel and fire up a pivot table and figure out how to look at it, but it's oftentimes easier just to declare a parameter and just assign it and display it. So if I say here, I say display tariffs. Let's call this barriers. And that's just a quick and dirty. Never works the first time. Oh, what's the name of the sector? What's the name of the sector? I don't have the sector right.
G.
Is it PRM? Is that GAMS data, GTAP 10, WinDC sectors. Oh, PMT.
Hmm.
Yeah.
Wasn't finding anything.
Yeah, PRM was not there.
There's another, oh, okay, you said exit that, okay.
It's probably an error because I'm probably dividing by 0. I bet there's some sectors there's no trade flows. So we have undefined US into US, so that makes sense. But that shows VTWR 5%. Tariff rates are really small, like less than 1%, right? The subsidies, there's subsidies from China. It has subsidy giving a 3% subsidy on China. Rest of the world around 2% subsidy. And let's want to look at let's throw in what the flow is as well. So this is going to
So
be,
this is in 2014.
yeah.
Okay.
And now you're about to put a 25% tariff on all that, right?
Yeah. I'm just saying, I only want to do these assignments for countries that are exporting. I just want to see what the trade flows are. Well, the cool thing is, if there's interest in this, it's easy to formulate. We take the cool thing about this is changing the database doesn't change any of the programs. So if we go out and build the database with GTAP 11, then there for 2017, then you can get the most recent data. But this has got VXMD, so we can see Canada is the biggest exporter. Rest of the world collectively is somewhat bigger, but on a bilateral basis. And that's got China's only got 8, right? And so then now if we go in here and say, okay, well, let's go in and do it, and this is going to dependent. So apply a tariff, 25% tariff. I have to set the iteration limit back up to a big number.
And remember to change the sector.
It's PMT.
Yeah.
The other one.
or the-
And we'll just look at the thing.
2 minutes to 20.
Yeah, I know, I gotta get going.
This is the exciting stuff. This is the exciting part, right? here.
Exactly. Exciting.
So US imports go down by like 6,
33%?
yeah, 66%, right?
66%.
It's a huge decline in imports. It's really amazing, actually.
Oh, yeah.
Unexpected. And now we can do the same experiment. Let me just say, I've got 2 minutes. Let me see if I can do the same experiment in the other one. So that's GTAP when DC sale. Now I'm going to say GTAP when DC. This thing, every time I edit it, comes back.
So you could create a set of a bunch of tariffs, right? Don't do this right now. But then you could run a bunch of scenarios with that.
No problem.
Yeah, that's, I mean, no
It's
sweat.
exactly, it's
Yeah.
exactly what we did with the energy model.
With the energy, that's what I'm thinking, how we can
Just you
use this.
define the set.
And you could go and see what the, how the imports are impacted with every level of tariff.
Yeah, right. Yeah, yeah,
So
no,
that's
so-
things I think, right?
Yeah.
Natalie chime in that we would like to see.
No, I'm trying to share that once you get a model that sort of has the key idea, then using the model and again, I tend to get excited about mundane things, but the fact that you can use all your processors too, you can launch these guys and run
Yeah.
them in parallel. It's great. You can do lots of damage with these modern computers. They go. So now if I'm going to go here, I have to